So percent error problems look at how close we were to getting it right. So one of the things you have to recognize is what is right. So when we're reading this problem, it says that Chase measured it to be 14 inches, but that the actual length was this. So if he would have gotten it right, this is what he would have gotten. Okay, so we know we don't know the percent, but we know if he would have been 100% accurate, he would have gotten exactly 13 1/10 inches. How far off was he is what we need to figure out goes there. So to figure that out, we need to subtract what he actually got, the actual measure, minus what he was supposed to get. You can do it the other way as well. And in this case, he was over, so it's going to be a positive value. But it's always going to be actual minus the correct, and you just got to know if it was over or under. So in this case, we got that it was 9/10 of an inch over. And now we're going to go ahead and solve it. And we've learned that to solve a proportion, we cross multiply. 13 1/10 times the percent is 100 times 9/10, which is 90. And then we go ahead and divide both sides by 13 1/10. And that gives us the percentage to the nearest tenths place would be about 6 9/10%. Okay, percent change means what was the effect of the increase or decrease, and sometimes we want to look at what was the percent. So in this case, we know the percentage. We know that in our percent proportion, it's always out of 100, and it says we went down 2%, our robberies, and the result was 245. So this is after it went down. Okay, and it started in 2013, which isn't a significant number. We don't need this number at all, but it's just for clarification. So in 2013, it started. So this is our original amount was in this year. So that's what our unknown is, what our original amount. So we don't know right now what it was in 2013, so that's our variable. But we know that it decreased from whatever this was by 2%. So remember, this represents exactly 100%. So when it started at 100% in 2013, it decreased by 2%. So what percent was left in 2014 of the robberies? So that means we had 98% of what it was in 2013. So sometimes we have to start off by doing some addition or subtraction. And in this case, we'll subtract that 2%. So that 245 represents what it is now. So that's 98% of what it was in 2013. And now we're ready to go ahead and solve. So we cross multiply. 98 times x, 100 times 245. And now we go ahead and do the math. 24,500 divided by 98 gives us that we have 250 robberies in the year 2013. And so if we go ahead and do 250 minus 2%, we get 245. Okay, so now this one's percent increase or decrease. So it says, when a number is decreased by 9%, the result is, so it's not what it started from, this is what we got to. So that's our part, not the original, because it's asking what is the original number. Remember, original is going to go in our denominator, so part needs to go up here. So if the percentage decreased by 9%, that means what we're left with is what percent? Well, if it was originally 100% and we decreased it by 9%, that means we're left with 91% of its value. So that means we have to make this number up here not 9%, but 91. And so now we're trying to figure out what was our whole, or what was our original number. So now we're ready to go ahead and solve. So we have 91 times x and 48 times 100. And now we go ahead and divide both sides by 91. And to the nearest tens place, we get 52 and 7/10. And if we go ahead and do 52 and 7/10 minus 9%, we get about almost exactly 48 when we round it. Okay, now these were those multi-step percent and increase problems. Okay, so it's 2008. I remember it. You may not. And a person bought a new car, and the cost of the car was $29,500. Every year after that, the value of the car depreciated by 14%. So it's 14%, and it's year one. And then it says now we want to know how much it is, and it's 2012. So that was 2008. Oh, sorry. When they got it. So that means it's going to be 2000 what after year one? 2009. So in 2010, it's another 14%. And then it's going to be another 14%, and now it's 2011, and then it's going to be another 14%, and it's 2012. Okay, but it says how much it's going to be in the year 2012. Okay, now, it's not just a matter of adding up those percentages and then going ahead and taking that off of the car. It's because this is a little bit of a weird problem. So we're trying to figure out how much we're going to get out of the car after we depreciate it. So remember, what is the actual value of the car? Remember, it's 100% to start. And then we decreased it by 14% each year. So that means the car is maintaining 80 was at the beginning of each year. So that's what I'm trying to find out. What is 86% of its beginning of the year value? And so in year one, its value started at $29,500. And what does it end at? So that's its 100% at the beginning of year one, and we want to figure out what is its end of year one. So we go ahead and we cross multiply, and 29,500 times 86% is 25,370. Now the directions say to round to the nearest $100. I'm going to do that at the end, and that's because I'm using a calculator and it can keep all these decimals for me. Okay, so now I know that at the beginning of year two, the car's value is this. And when I deduct 14%, I can do this a little bit easier than doing a proportion every time, because what I'm really doing is every year I'm trying to figure out what is 86% of blank. And this is always the previous year. Previous. Okay, so if the previous year was 25,370, what variable is equal? 86% goes in as a decimal, of means multiply, and then I'm just substituting the previous year. So in this case, the previous year is 25,370. So I go ahead, do the math. I'm going to take off the cents on this one, and it gives me that it's about $21,818. And that's at the end of year 2. So that means I'm starting year 3 at 2118. So that's year 2. So year 3, I'm going to do 86% of 2118, and I get that it's about $18,763.48. So I'm just going to drop the 48 cents. And so that means at the end of year 3, it's 18,763, which is how we're going to start our last year. And so to get the year 4 value, or 2012, I'm going to do 86% of 18,763, which would give me about $16,136.18. And if we rounded it to the nearest hundreds, it would be $16,100. Now, the thing is depending on where you actually started rounding, your answer could vary on this, which could cause some variation on what numbers that the Delta Math actually would accept.